Hello, in this chapter we're going to be talking about the concept of friction. Specifically, we're going to be talking about dry friction, which is the type of friction that exists between two solid bodies. At its core, friction is just a force. We're going to apply this in equilibrium just as we would for many other scenarios, but friction is a little more complicated and we have many applications built on this, so we've devoted a chapter in the book to this. So the first of those applications that we're going to be talking about with dry friction is the idea of slipping versus tipping. So this is where if we have a body and we start kind of pushing it along a surface, is it going to slide along the surface or is it going to tip over when we push this object because of the friction force? So at its core, that is a question of comparing the friction force, which is part of this, as well as the couple that we're going to get from the weight force and the normal force. And if it's kind of a large enough couple from the friction force and the pushing force, we overcome that other couple and we're going to have the object tip over. Application number 2 is with wedges. So a wedge is anything that's kind of used to push between two objects. We can get a lot of separating force if we have a small enough angle on that wedge, but we're going to be fighting friction in many of these cases. So at its core, it's equilibrium analysis plus kind of a heavy application of friction. Also with wedges, if we imagine kind of a ramp or a wedge turned around a shaft, that's the idea of a power screw. So a power screw is any object that is kind of a screw-driven system. And many of the same equations that go into play with wedges are going to come into play with power screws. We just simply have the rotation added to that piece. Next up as an application, we have the idea of bearing friction. So in any shaft-driven system, we've got bearings. That's where we have the interface between the rotating shaft and the non-rotating kind of supporting mechanism for this whole thing. And so for simple bearings where we just kind of have a shaft and a surface around that, we can use the dry friction equations to find out the kind of resistance to rotation we get from our bearings. Next up, we have the idea of disk friction. So this is where we have a spinning surface pressed up against a non-spinning surface. And sometimes we want to reduce the friction in this case. We want rotation to happen. Other times, friction is the entire point. So the biggest application here is the idea of disc brakes. So disc brakes take a rotating disc and the non-rotating calipers, or the non-rotating brake pads from the calipers, and the friction in that, which is a type of disc friction, is what's going to stop most cars and most vehicles today. Finally, with the friction applications, we have the idea of belt friction. So anytime we've got a belt-driven system, we're kind of transferring power from one input to some output using a belt. That system is relying on friction to transfer the power. If we don't have sufficient friction, the belt is going to slip and we're not going to be transferring the power effectively. So with that, that's all I have for the chapter on friction and friction applications. Thank you for watching, and I hope to see you again.